Okay, the next two videos here that we're going to look at are going to be just looking at some more examples of doing circuit simulation. And actually you can see the, before I do that, you can see the result of my last video here that I realized that I forgot to put a cosine here. So actually, if you want to say from the previous lesson, this output, I'll just rewrite it here, should be 188.43 cosine omega t minus 42.88 degrees. So I mean that's actually what it should be. Several of you already caught that, but since that was really the only mistake, I decided not to remake that video. Alright, so let's look at another problem here. So getting my problem here, I need to sketch my circuit out. So we're going to have a capacitor here that is minus J8 ohm, and that's going to be in parallel with the series combination of a J4 ohm inductor and a dependent voltage source that is 2.4 I delta, and then I delta is the current going through that capacitor we drew, and then that is in parallel with a 5 ohm resistor, and that's finally in parallel with a current source that is 10 plus J10. Now notice this problem didn't actually, not ohms, hello, amps. This problem didn't give us any frequency, and it already gave us everything in impedance form, which is kind of nice. Now it's asking us to find the voltage across the 5 ohm resistor. Now we can use any technique that we want to here, but we should notice here that I really only have two nodes. Well, technically there's three nodes. There's a node right here too, but I'm not really going to use that. So I've got the node at the bottom, which of course is 0 volts, and then this node at the top would be the output voltage that we're looking for. So from this, you can get that I delta is equal to V out over negative J8, because the current through that capacitor would of course be the output voltage divided by negative J8, which you could rewrite if you wanted to as positive J V out over 8. Alright, so now we're going to write a node equation here, and we're just going to write actually we're going to have to write two node equations. I wasn't quite careful here. Oh yeah, no, we won't have to write two node equations. I was just thinking through here for a second, because we need to know this voltage right here. So, but that voltage here is that 2.4 I delta, so I'll call this VB. And so I'll write it off to the side here. VB is 2.4 I delta, which would be 2.4 J V out over 8, which I'll just write as J 2.4 V out over 8. Alright, so now we are ready to go ahead and write our node equation. And so I'm going to do it as the current coming in is equal to the current leaving. So I've got three currents leaving this node. I drew in blue there, and then one current coming into the node. And so what we'd end up having here is the current coming into the node, 10 plus J10, is equal to the current, of course, leaving the node, which that would be V out over 5 plus V out minus VB over J4 plus V out over minus J 8. Now, I know we know what VB is at this point, but before I substitute it in, sometimes it's better not to substitute in right away and to simplify the equation you have first. And so I'm going to do that by going ahead and multiplying. In this case, I'm going to go ahead and multiply by J8. I mean, there's lots of things you could multiply. You could multiply it by 8. You could have multiplied by negative J8. I'm just going to do J8. So on the left-hand side, I've got J8 times 10 plus J10, which we'll do in a second. And actually, I'm going to back up here. I don't want to do 8. Some of you might have said, why are you doing 8? I want to do 40, because that's going to clear everything out. So I'll have J40 times 10 plus J10 is equal to, well, this would be J8 VO, and then plus, well, the J's are going to cancel, and so I have 40 divided by 4, so I'd have 10 V out minus VB. J's are going to cancel, and then I have 40 divided by 8, so I'd have minus 5 V out. And then if we do some calculations here on our calculators, let me pull mine up here a second. Alright, so we have 40J times 10 plus 10J, which, yeah, I mean, this is something that you could really do in your head, but I was just using my calculator to double check. So you get negative 400 plus J400, and then this is going to be equal to, well, let's go ahead and combine some like terms here. So I've got 10 V out minus 5 V out, so I'm going to have 5 plus J8 V out minus 10 VB. Alright, so now let's take this equation here for VB and substitute it in now. And the reason I waited to substitute it in until now is because, again, I cleaned up my equation first. Alright, so then we got minus 400 plus J400 is equal to 5 plus J8 V out minus 10 over 8 times J 2.4 V out. So doing that computation, we get minus 400 plus J400 is equal to 5 plus J8 VO minus J3 VO. So obviously combining like terms and then dividing both sides, we get negative 400 plus J400 divided by 5 plus J5 is equal to V out. And so then we just do that computation. And when I did that computation, I got that this was equal to J80 volts. So V out is equal to J80 volts. But then we should go ahead and again try and put these always and write them as cosine functions. So this one, converting it to polar form is easy. You can use your calculator, but this is really a trivial one. This is just 80 at an angle of 90 degrees. Remember, those 90 ones you want to really be familiar with. And so this would mean that my V out is equal to 80, I should put volts there, and remembering to put the cosine down this time, omega t plus 90 degrees volts. And so that would be my final answer.